Okay, good morning everyone. So we will start today's class. So it's a new topic that is three phase. Okay, three phase AC system. So till now we were discussing about single phase and we have done a lot of analysis of pure resistive circuit, pure inductive circuit, pure capacitive circuit. Also we have seen how to represent AC quantity using a phasor. So the same thing is applicable for three phase also. ഓക്കെ ആ ഫേസറിന്റെ ആ ഒരു ഇത് നമുക്ക് ഈ ത്രീ ഫേസിന്റെ കാര്യത്തിൽ നമുക്ക് ആവശ്യമുണ്ട്. Okay, so what is the difference between single phase and three phase? That is what we are going to discuss today. Okay, so you can see that there are two diagrams in that. Both are diagrams of generator. For the first one, the top one which you are seeing in this diagram is of single phase, and the bottom one which you are seeing in this figure is of three phase. Okay, so what is the difference between these two diagrams? You can see that in the first diagram there is only one winding. You can see that two windings are there, but actually it is one winding. One end of uh, this one winding is on the top and another end of the winding is the bottom. It is constructed in that manner. Okay, this is only a single winding, R and R dash. One end of the wire is R and another end of the wire is R dash. So it's a single wire, single winding. But if you observe the second diagram, you can see that like that there are three such winding. You can see that this is R winding. Here you can see one R winding. This is the R dash of or opposite end of that winding. Okay, that is includes both of them together forms a single winding. Okay, R and R dash is a single winding. Then you can see B here and B dash here. That is another winding, second winding. Okay, and you can also see that Y is here, Y dash is here. That is the third winding. Okay, so the difference between single phase and three phase is there is only one winding in a single phase generator, but there are three such windings are there in three phase generator. And how this work? Okay, see in both the generator you can see a magnet at the middle, north and south pole. Both the generator you can see magnet. Okay, this is north and south pole of the magnet, and you can see another magnet in the single phase machine also. So what will happen is when it is rotating, actually the magnet is rotating in this case. Okay, when this magnet is rotating, you can see that when it comes to near to the winding, there is a lot of changes in the flux linkages. For example, when north pole is coming from this side to this place to the current place. Okay, so even other current place like movie and something, there will be a lot of changes in the flux linkages. Okay. We all know that as per Faraday's law, whenever a magnetic flux linked with a coil changes, an EMF is induced in the circuit. So as this rotor keep on rotating, the flux linked with this coil will change, and due to the flux change, due to the change in linkages, EMF will be induced. And also we know that the second law, the magnitude of induced EMF is equal to rate of change of flux linkages. Okay, so how fast it is rotating depends on that voltage will be, and voltage magnitude will be increased. So here only one winding is there. You can see that in that winding, okay, in that winding a voltage is induced like this. as it rotates. Assume that when north pole comes closer to R phase, the maximum induced EMF is induced in the circuit. So as it rotates, what happens? This value changes because flux linkages. There is a change in flux linkages, and when the north pole turns 180-degree and reaches R dash winding, uh, R dash will be having more amount of voltage than the R winding, so it will go to the negative side of the supply. Okay, so the question is similar to this. Okay, so this is one diagram. So what I am going to do is I am going to place another winding here. One more winding here. Okay, one more winding here. That is doesn't have any connection with the first winding, R winding, and opposite end I am placing it here. Okay, this I am calling it as Y winding, and opposite end is Y dash. So what happens here also? So if you look at this diagram, I have placed Y winding 120-degree away from the R winding, almost 120-degree away from the R winding. Okay, so what happens is due to the rotation of this magnet, EMF or flux linkage with the Y winding also will change, and EMF will be induced in the Y winding. Okay, അത് ഒരു വൈൻഡിങ് കൂടെ ആഡ് ചെയ്തുകൊണ്ട് അവിടെ ഒരു ഡിഫറൻസ് വരുന്നില്ല. ഫാരഡേസ് ഫസ്റ്റ് ലോ അവിടെ വർക്ക് ചെയ്യും അല്ലെ? എന്തായിരുന്നു ഫാരഡേസ് ഫസ്റ്റ് ലോ? Whenever a magnetic flux linked with the circuit changes and EMF is induced in the circuit. So since we have another one more winding called Y, there is also a coil. One end of this Y is Y and another end is Y dash. So what happens when this magnet rotates? Flux linkage with Y will change. EMF will be induced in the Y winding. But there is a slight difference when you compare EMF induced in the Y winding and R winding. What is that? It is the difference due to the phase due to the 120-degree gap between R and Y. R ഉം Y ഉം തമ്മിൽ 120-degree gap ഉണ്ട്. So because of that gap, there will be a change in induced EMF. Okay, when I said earlier, okay, when north pole comes closer to R winding, maximum induced EMF is induced in R winding. Okay, at the same time, what happens to Y winding? North pole is not come near to has not come near to Y winding, so EMF induced in the Y winding will be lesser than that. And as it rotates, at a point, this north pole will come straight to Y winding. So what happens? Maximum EMF will be induced in the Y winding. At the time, at the R winding, voltage induced will be very less. So there will be a 120-degree difference between what? Between R and Y winding. Okay, you can see the second diagram, second waveform. The voltage induced in the R winding is marked in red in color, sorry, black in color, and you can see that the voltage induced in the Y winding is marked in red in color. If you closely observe that, the R winding reaches the peak value at this point, and after 120-degree, what happens? Y winding goes to the peak value. So what I can do is I can draw it and show you. First I am drawing the axis, x-axis, then y-axis. Okay, so what you do is we can draw AC voltage like this. So this is the voltage because I am taking R winding as a reference. So this is the voltage correspond to R winding. And what else I know is, I know this is 360 degree. One cycle is 360 degree. and this point is 180 degree, and the center one is 90 degree. So in between this, it will be 135. And see, what happens is, I can say that since it is rotating, okay, first it will reach R winding, then after 120 degree, it will reach Y winding. So I can say that the voltage at the Y winding is lagging behind R winding by an angle 90 degree. Okay, by an angle 90 degree. So what again I am going to do is, since for a half cycle it is 120 degree, what I can do is I can divide this half cycle into 3. So first 60 I am marking here. So example, this is 60, this is 120, and the third one is 180. So what I should do is I should draw in such a way that it is lagging behind 120 degrees. So I should start from here. I should start from here. It goes like that. Okay, that means after zero crossing of R winding, okay, zero crossing of R winding happened here. After 120 degree, zero crossing Y is happened. Okay, it is happening at 120 degree. Then again, I can divide this as I didn't. I can divide this by 60 degree. So this is 180. This is 240. This is 300. Okay. So 120. After reaching 120, it will go to at 300. What happens? It comes to 0. And like this waveform, I will get. Okay. ഒന്നുകൂടെ പറയാം. R winding ഉണ്ട്, Y winding ഉണ്ട് അല്ലേ? So it is straight to R winding where the peak value or peak induced voltage happens. And then it rotates, and after 120 degree it comes closer to Y winding, and the peak value of Y winding happens at that point. So there is a difference between the waveform of R winding and Y winding. What is the difference? The difference is Y voltage at Y winding is lagging behind R winding by an angle 120 degree. Okay, ഒന്നുകൂടെ നമുക്ക് ആ waveform വരച്ച് നോക്കാം. Okay, again we will draw that waveform. First you draw the x-axis and y-axis. Okay, then what you do is then you draw R winding because that is our reference. Then this is the waveform of R winding. And we know that this is 360 degree. This is 180. Okay, then what I'm going to do is I'm going to divide this by 60 degree. Okay, so divide x-axis by 60 degree. So I can say that the first line is 60, second line is 120, third line is 180, fourth line is 240, then fifth line is 300, then this is 360, then this is 420. I can divide like this. And now I know that Y winding voltage at Y winding is lagging behind by a angle 120 degree. That means if you take this point, R winding is crossing exactly 0 at this point. So after that, after 120 degree, Y winding should cross 0. So I can write like this. And I can also say that R winding reaches its peak value at 90 degree. So Y winding should reach at 210. Okay, 90 plus 120. That is 210. So that comes somewhere here between, this is 180, this is 240. So somewhere here it comes. So I should go like this. And R winding crosses 0 at 180 degree. So after 120 degree, so 180 plus 120 degree, 360, 300. So this is 300. So we should cross 0 at 300. So I should draw like this. Okay. Now what I'm going to do is, I have already told that I have placed a Y winding here, 120 away from R winding. I'm going to place one more winding as you can see in the second diagram, that is B winding. Again, it is also 120 degree from Y winding. It is also placed 120 degree away from Y winding. Okay. ഇപ്പോൾ ആറും ബിയും തമ്മിലുള്ള ഡിഫറൻസ് എത്രയെന്ന് ചോദിച്ചാൽ 240 ആണ് അല്ലെ. ആറും വൈയും തമ്മിലുള്ള ഡിഫറൻസ് 120 ഡിഗ്രിയാണ്. വൈയും ബിയും തമ്മിലുള്ള ഡിഫറൻസ് എത്രയാ? 120 ഡിഗ്രിയാണ്. Okay, so what I can do is, I have placed B winding here after Y phase. Okay, so opposite of B is B dash. It is also placed just opposite to that. And now I can say that with respect to R winding, if you observe, it is placed 120 degree away in the clockwise direction. But if you take the anti-clockwise direction, it is placed minus 120 degree away. Sorry, and uh, if you take R as a reference, R winding as a reference, you can say that B winding is 240 degree away from R winding. Or you can say that, or in clockwise direction, or you can say that B winding is 120 degree away from R winding in the anti-clockwise direction. So I am seeing like, so when it is rotating, north pole will come to B winding and then later it will go to R winding. So I can say that the voltage at B is leading B winding, sorry, R winding, voltage at B winding is leading R winding by an angle 120 degree. So here it is crossing 0. At this point it is crossing 0. So I can say that B winding, voltage at B winding should cross 0 here. So what I can do is, I can draw waveform like this. Okay, it should cross 0 here, and after 90 degrees it should reach peak value 60, 150 by 150 should reach peak value, and after reaching peak value, again 60 plus 240, at 240 it should cross 0. So I should draw like this. So this is what I have drawn here. You can see the waveform here. Okay. So so in a single phase generator, there was only one winding. That winding actually has two ends. One is R and R dash. Okay. And inside the generator, there is a rotating part. And now in this case, we are assuming it as a permanent magnet. So it will be keep on rotating. When north pole comes closer to this particular winding, maximum EMF will be induced in that winding. Okay. Now I have taken the same generator. What I am going to do is, I am going to add another winding, and winding name is Y, and it is placed 120 degree away from R winding. Okay, so what happens is, as this rotor rotates, rotor will reach straight to R winding at an angle, and 120 degree after that particular angle, it will reach closer to Y winding. So I can say that the voltage at Y winding is lagging behind R winding at an angle 120 degree. And then after drawing the waveform again, what I'm going to do is I'm going to draw I'm going to place another winding called B winding, where this B winding is placed again 120 degree away from Y winding or 240 degree away from B winding. Or I can say that in the anti-clockwise direction, the B winding is placed 120 degree away from R winding. That is in the anti-clockwise direction. So I can say that the voltage is actually leading R winding. Voltage at B winding is leading R winding by an angle 120 degree. So I can draw a waveform like this. ഓക്കെ, ഇത് എങ്ങനെയാണ് വരച്ചത്? ഫസ്റ്റ് ഒന്നും കൂടെ ഞാൻ പറഞ്ഞത്, ഇത് വരക്കുന്നത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്, വരക്കുമ്പോൾ തെറ്റിപ്പോകാൻ പാടില്ല. സോ ഫസ്റ്റ് യു ഡ്രോ എക്സ് ആൻഡ് വൈ ആക്സിസ്. Okay, then what you do is, then you draw voltage at R winding. So this is voltage at R winding. Okay, then after drawing this, you can understand that this is 360 degree. This is 180 degree. Okay, so since the duration of positive half cycle is 180 degree, I can divide this into 3. Okay, so I can say that this is 60 degree. This is 120 degree. Okay, 60 degree, 120 degree, and this is 180 degree. Okay, again I can divide this into 2. So 60 degree by 60 degree. Okay, so after 180 degree, 240 degree will come, and after 240 plus 60, that is 300. Okay, now I have already drawn. I can say that voltage at Y winding is lagging behind R winding by an angle 120 degree. So here you can say that it is close to 0. Okay, voltage at R winding close to 0 at 0, and after that 120 degree, what should happen? The voltage at Y winding should cross 0. So I can say that it is something like this. It will come. Okay, so at this 120 degree, as we have seen in the case of VR, it is close to 0. And we know that after crossing 0, it took 90 degree to reach the peak value. So after crossing 120 degree, it should take 90 degree to reach the peak value. So 120 plus 90 is 210. So it will come somewhere here between 180 and 240. So 210 point is here. So I should draw like this. After reaching 210, again it will take 90 degree to reach 0. So 210 plus 90 degree, 300. So at 300 exactly it will come 0. So I can draw the second Vy like this, voltage at Y winding. Again, look at the third winding. I can say that voltage at B is leading R voltage. Okay, so what I'm going to do is, so I can say that VR has crossed 0 at 180 degree. So since VB is leading, it should cross 60. 60 കാരണം എന്നാലും 120 degree difference വരും. Okay, if it is close to 60, it should reach its peak value by 60 plus 90 degree. So at 150, around 150, that is this point, it is between 120 and 180, it should reach peak value. So once after reaching peak value at 150, around 240, it should reach zero value again. So I can draw it. So then I can complete this. So this is a three-phase waveform. You should draw like this. Okay, you can see the expression here for each voltage. VR is nothing but instantaneous value expression. Okay, VR is nothing but Vm sin omega t. Vy is nothing but Vm sin omega t minus 120 degree. എന്തുകൊണ്ടാണ് Vy winding 120 degree away ആണ് place ചെയ്തിട്ടുള്ളത് R നെ compare ചെയ്യുന്നത്. Because I have taken R as a reference. Okay, so VR is equal to Vm sin omega t. Again, Vy is placed 120 degree away from R winding, so it is Vm sin omega t minus 120 degree. The third winding Vb, if you can take R as a reference, if you consider R as a reference, I can say that Vm, the expression for Vb is equal to Vm sin omega t minus 240, because 120 plus 120 240. Now look at the phasor diagram. എവിടെയാണ് phasor diagram ഉള്ളത്? ഇവിടെയാണ് phasor diagram. So this is our phasor diagram. You can see that the R winding is placed, voltage at R winding is placed here 120 degree away. Voltage of Y winding is there, and again 120 degree or 240 from VR, we have VB, voltage at Vy. So this is how we have to draw the phasor diagram for a three-phase supply. Okay, ഇത്രയും ക്ലിയർ ആയോ എല്ലാവർക്കും? എന്താണ് what is the difference? എന്താണ് three phase single phase തമ്മിലുള്ള ഡിഫറൻസ് എങ്ങനെയാണെന്നും how to draw a three phase waveform എന്നുള്ളത് ക്ലിയർ ആയോ? എല്ലാവരും ആൻസർ പറയാം. എല്ലാവരും ക്ലിയർ ആയെങ്കിൽ ആയി എന്ന് പറയാം, ഇല്ലെങ്കിൽ ഇല്ലെന്ന് പറയാം. ആരൊന്നും പറയാം. ഇവിടെ ക്ലിയർ ആയില്ലേ എല്ലാവർക്കും? ഒന്നോ രണ്ട് ആൾക്കാരൊക്കെ okay. Okay, next one is advantage of three-phase system over single-phase system. എവിടെയാണ് നമ്മൾ ത്രീ ഫേസ് യൂസ് ചെയ്യുന്നത്? നിങ്ങൾ തന്നെ പറയാം, നിങ്ങൾ എവിടെയാണ് ത്രീ ഫേസ് കണ്ടിട്ടുള്ളത്? ത്രീ ഫേസ് നിങ്ങളുടെ വീടുകളിൽ യൂസ് ചെയ്യുന്നത് അല്ല വേറെ എവിടെയാണ് നിങ്ങൾ കണ്ടിട്ടുള്ളത്? നമ്മുടെ വീടുകളിൽ in our home and all, we are using single phase supply because we need only that much power, because what maximum we have is washing machine or load like washing machine, pump, then fans, etc. So the amount of power that is delivered by single phase systems are enough for that. But when you go for an industry or when you go for a place where high power equipments are used, there you require three phase to drive all those. Okay, നമ്മൾ റൈസ് മില്ലിൽ പോയി കഴിഞ്ഞാൽ നമ്മൾ അവിടെ കണ്ടിട്ടുള്ള ത്രീ ഫേസ് മോട്ടറാണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്, because we should protect all those machines, sometimes together, sometimes alone. We should protect like that. And if you go കുറച്ച് എന്താ പറയാ കുറച്ച് ചെറിയൊരു ഇൻഡസ്ട്രി ഒക്കെ നിങ്ങൾ കണ്ടിട്ടുണ്ടെങ്കിൽ they will be using three phase. ഇപ്പോഴത്തെ ഒരു ട്രെൻഡ് ഉണ്ട്, നമ്മുടെ വീടുകളിൽ വലിയ വീടുകളിലൊക്കെ നമ്മൾ ചെയ്യുന്നത് ത്രീ ഫേസ് കണക്ഷന് വേണ്ടി അവർ അപ്ലൈ ചെയ്യുന്നത് അല്ലെ. അതിന് കുറച്ച് പൈസ കൂടുതലാണ്, പക്ഷെ അതിൻ്റെതായ ഒരു അഡ്വാൻറ്റേജ് അതിനുണ്ട്. വീടുകളിൽ തന്നെ ത്രീ ഫേസ് സപ്ലൈക്ക് അവരെ അപ്ലൈ ചെയ്യുന്നു. So it is mostly commonly people used to use three-phase systems in industry where more amount of power is required for household applications and shops, etc. They will be using single phase. Okay, now about advantages of three-phase system or single-phase system. The first one is I can say that the output of three-phase machine is greater than that of single-phase machine. Okay, that is correct. Okay, output of three-phase machine, that is the power delivered by three-phase machine is greater than single-phase machine. Okay, then three-phase transmission lines require lesser amount of conductor material for transmitting same amount of power. Okay, if you want to, നമുക്കറിയാം നമുക്ക് കെ എസ് ഇ ബി ട്രാൻസ്മിറ്റ് ചെയ്ത് കിട്ടുന്ന പവർ ത്രീ ഫേസിലൂടെ വരും. നമുക്കറിയാം വലിയ പോസ്റ്റുകളിലൂടെ മൂന്ന് ലൈന് പോകുന്നത് നമ്മൾ കണ്ടിട്ടുണ്ട് അല്ലെ. അവിടെ നിന്ന് തൊട്ടടുത്ത ട്രാൻസ്ഫോമർ നിർത്തിയിട്ട് ട്രാൻസ്ഫോമറിനാണ് നമ്മൾ വീടുകളിലേക്ക് വരിക. അപ്പോൾ നമുക്ക് ഈ മുകളിൽ പോകുന്ന ലൈൻ എന്ന് പറയുന്നത് ത്രീ ഫേസ് ലൈൻ അല്ലെ. സോ നമ്മളിപ്പം ഒരേ എമൗണ്ട് ഓഫ് പവർ നമുക്ക് ട്രാൻസ്മിറ്റ് ചെയ്യണം ത്രീ ഫേസും സിംഗിൾ ഫേസും വെച്ചിട്ട്. ആ ഒരു കേസിൽ ത്രീ ഫേസ് വളരെ കുറച്ച് കണ്ടക്ടറെ ആവശ്യമുണ്ട്. ഒരേ എമൗണ്ട് കേട്ടോ, ഒരേ എമൗണ്ട് പവർ ട്രാൻസ്മിറ്റ് ചെയ്യുന്ന സമയത്ത് ത്രീ ഫേസ് സിസ്റ്റത്തിന് കുറച്ച് കണ്ടക്ടർ മാത്രമേ ആവശ്യമുള്ളൂ. ആൻഡ് ത്രീ ഫേസ് മോട്ടോഴ്സ്, third point, three phase motors are self-starting but single phase are not. Three phase motor is self-starting. Single phase motors are not self-starting. ഏറ്റവും നല്ല എക്സാമ്പിൾ എന്താ? The fan which we are using in our home. ഓക്കെ, നമുക്ക് ഫാനിനറിയാം, ഫാൻ ഒരു കപ്പാസിറ്റർ ഉണ്ട് അല്ലേ. ഫാനിന്റെ ഉള്ളിൽ നിങ്ങൾ കുറച്ച് ഗ്യാപ്പ് ഓപ്പൺ ആക്കി നോക്കിക്കഴിഞ്ഞാൽ നിങ്ങൾക്ക് മനസ്സിലാവും ഫാനിന്റെ ഉള്ളിൽ ഒരു കപ്പാസിറ്റർ ഉണ്ട്. ആ കപ്പാസിറ്റർ ഇല്ലെങ്കിൽ എന്ത് സംഭവിക്കും? ഫാൻ കറങ്ങില്ല. എന്തുകൊണ്ടാണ്? കാരണം അത് സെൽഫ് സ്റ്റാർട്ടിംഗ് അല്ല. ആ ഫാനിന് അങ്ങനെ സ്റ്റാർട്ട് ചെയ്യാൻ വേണ്ടി പറ്റില്ല. ഫാനിന് ഏത് മെഷീൻ എടുത്താലും, റൊട്ടേറ്റിംഗ് മെഷീൻ എടുത്താലും, ഇറ്റ് റിക്വയർ എ റിവോൾവിംഗ് മാഗ്നറ്റിക് ഫീൽഡ്, ഒരു റൊട്ടേറ്റ് ചെയ്യുന്ന ഒരു മാഗ്നറ്റിക് ഫീൽഡ് വേണം. So when there is only a single winding, the magnetic flux will not be rotating. So in order to make a rotating magnetic field, we are using capacitor in single phase motor. Okay, so it is, if you use a capacitor in a single phase motor, it acts as a secondary winding. So it is support the rotating function of the motor. But for three phase, we doesn't require this capacitor starter because we know that it is having a rotating magnetic field because each winding is placed 120 degree away from the other. So it will be rotating. Once R winding reaches the peak value, after 120 degree, Y winding reaches the peak value. After 120 degree, again B winding reaches the peak value. So it will be rotating like that. So three phase induction motors are self-starting. Rectified three-phase voltages are smoother than single-phase. You got a waveform like this, pulsating DC. But if you go for three-phase rectification, you will be getting a output voltage like this. It will be almost straight. So the rectified three-phase voltages are smoother than of three-phase systems are smaller than single-phase. Size of three-phase system 1.5 HP motor of both single-phase and three-phase. What will happen is the size of three-phase will be lesser than single-phase motor. Another size for animal. Okay. So what are the advantages of three-phase system? One is output power is more in three-phase system compared to single-phase system. And second point is lesser conductive materials is used in three-phase system. Third point is single-phase motors are not self-starting, but three-phase motors are self-starting. Fourth point, rectified output voltage of three-phase is smoother than single-phase. Last point, the size of three-phase system for the same power are smaller than single-phase. Okay, ഒന്നാമത് ഔട്ട്പുട്ട് കമ്പയർ ചെയ്യുമ്പോൾ ത്രീ ഫേസിന്റെ പവറാണ് കൂടുതൽ. രണ്ടാമത് കണ്ടക്റ്റീവ് മെറ്റീരിയൽ നോക്കുമ്പോൾ ത്രീ ഫേസിന് കുറച്ച് കണ്ടക്ടർ മാത്രമേ കുഴപ്പമില്ല. മൂന്നാമത് സെൽഫ് സ്റ്റാർട്ടിങ്, അതായത് സിംഗിൾ ഫേസ് എന്ന് പറയുന്നത് സെൽഫ് സ്റ്റാർട്ടിങ് അല്ല, ത്രീ ഫേസ് സെൽഫ് സ്റ്റാർട്ടിങ് ആണ്. നാലാമത്തെ പോയിന്റ് റെക്ടിഫൈഡ് ഔട്ട്പുട്ട് വോൾട്ടേജ് എന്ന് പറയുമ്പോൾ ത്രീ ഫേസിന്റെ സ്മൂത്തർ ആണ്. അഞ്ചാമത്തെ പോയിന്റ് സൈസ് നോക്കുമ്പോൾ ത്രീ ഫേസിന്റെയും സിംഗിൾ ഫേസിന്റെയും സെയിം പവറിനെ കമ്പയർ ചെയ്യുമ്പോൾ ത്രീ ഫേസിന്റെ സൈസ് കുറവാണ്. അത്രയും കാര്യങ്ങളാണ് നമ്മൾ പഠിക്കുന്നത്. അപ്പൊ എനിക്ക് മെയിനായിട്ട് നിങ്ങൾക്ക് ഈ ഒരു വേവ് ഫോം എങ്ങനെ വന്നത് മനസ്സിലാക്കണമെന്ന്, ഇപ്പൊ നിങ്ങൾക്ക് അത് നോക്കി മനസ്സിലാവുന്നില്ലെങ്കിൽ യൂട്യൂബിൽ ആനിമേഷൻ വീഡിയോസ് ഒക്കെ ഉണ്ടാവും, അത് നോക്കുക, നോക്കി പഠിക്കും. സോ അറ്റൻഡൻസ് എന്ന് പറയാം. അഭിറാം പി പി.
Present, sir.
അഭിജിത്ത്.
Present, sir.
ആദിത്.
Present, sir.
ആകാശ്.